We're counting down the 10 aircraft that every expert mechanic would actually buy, ranked by what matters most when it's your own money on the line. From underrated classics anyone can fix with off-the-shelf parts to machines purpose-built for extreme reliability and total repair freedom. Each entry earns its spot through proven, real-world maintenance savings. Forget the glossy showroom favorites. This list is about tools, not toys. Which airplane sets the unbeatable standard? Let's begin with number 10. Cessna built more than 30,150s and over 7,152s. These airplanes outnumber just about every other certified single on the ramp, and for one reason, they are nearly impossible to kill. Mechanics call them the cockroach of general aviation, not glamorous, but they survive anything. The secret is standardization. Under the cowling, the Continental 0200 and the Lycoming 0235 are the simplest certified 4-cylinder engines you can buy, and they are everywhere. A current field overhaul. Quote for an 0200 runs between $12,000 and $18,000, parts and labor included. That's a real invoice from a reputable shop, not a lowball number. Compare that to the $35,000 to $50,000 you will pay to overhaul the bigger engines used in high-performance singles or modern composites. Parts for a 150 or 152 are never more than a phone call away. Salvage yards are stacked with wings, cowlings, and control surfaces. PMA suppliers churn out everything from pistons to alternators, and many common items cross over with automotive or industrial hardware. If a starter fails, a mechanic can have a replacement on the bench the same afternoon. Avionics? Minimal. Systems? Basic. There is almost nothing that is not mechanical and almost nothing that cannot be fixed by a mechanic with a wrench and a manual. The knucklebuster score starts here: low cost, high parts availability, and the fewest surprises on the bill. The Cessna 150 and 152 are not fast or flashy, but in the world of life cycle costs, they are the gold standard for simplicity and survival. Cessna's 182 Skylane has long been the go-to for pilots who want utility without the headaches. The secret is not just what is under the skin, it is how you get to it. Mechanics talk about the Skylane's cowling with real respect. Unlike the one-piece composite shells found on many modern singles, the 182 uses a split-hinge cowling that opens wide, earning it the nickname barn door. With both sides swung open, the entire engine bay is exposed. Oil filter changes, spark plug swaps, and accessory checks all happen in plain sight, not through contorted arms and scraped knuckles. In a typical shop, a timed oil filter removal on a 182 can take less than 10 minutes from latches to safety wire, often with just a handful of tools and no acrobatics. Contrast that with the multi-panel specialty fastener routine required on newer composite aircraft, where even a basic oil change can balloon in labor hours. Mechanics routinely record fewer tool changes, less panel removal, and faster turnaround on the 182. Every minute saved is a dollar not spent on labor. The engine itself, the Continental 0470, has a reputation for being low stress and forgiving. It is not tuned for the last knot of speed or maximum horsepower, which means fewer surprises during annual inspections. Real shop invoices for 182 annual inspections often land in the $3,000 to $5,000 range, even after a few squawks. That is not pocket change, but it is a far cry from the 5-figure bills that can haunt owners of more complex, tightly packed designs. For mechanics, the 182 is not just easier to work on, it is a reminder that accessibility is not about luxury, it is about saving time and money year after year. The Grumman Tiger AA5B doesn't look like a hot rod, but mechanics know it's the clever outlier in the speed game. With fixed landing gear and a Lycoming 0360 engine, the Tiger cruises at 135 to 140 knots. True airspeed, matching the numbers of older retractable singles, minus the headaches. There is no hydraulic pump, no gear motor, no swing test ritual before every annual. The gear just works every time, and the maintenance bill stays in check. It is simple. The real trick lies in the bonded wing. Instead of rows of rivets, Grumman used large smooth aluminum skins glued together, reducing drag, saving weight, and skipping the labor of driving thousands of rivets. That is how the Tiger squeezes out extra knots without adding complexity. Fewer protrusions mean less turbulence, and the airframe stays slick year after year. One owner said he sees 138 knots while burning 9 gallons per hour, and his mechanic never calls with surprises. For mechanics, the Tiger is a breath of fresh air. The O360 is everywhere, with parts on every shelf and overhaul shops quoting mid-teens for a full rebuild. There is no gear system to leak or fail, and annuals do not balloon with hidden labor. The only trade-off is inspection. Bonded joints take a trained eye, and corrosion can hide beneath the skin. But compared to the cost and downtime of fixing a misbehaving retractable, the Tiger's simplicity wins. It ranks 8th because it is fast, honest, and just complicated enough to keep things interesting without ever punishing you for wanting a little more speed. Mooney's M20C and M20E models do not just chase speed. They do it with a kind of mechanical honesty that mechanics quietly admire. The secret is the Johnson bar, a hefty lever sitting between the seats. Instead of trusting electric motors or hydraulic pumps, the pilot moves the gear with pure muscle, locking it up or down in one clean motion. There is no relay to click, no micro switch to fail, no hydraulic fluid to leak onto the hangar floor. You get instant binary feedback. The bar is either locked or it is not. For a mechanic, that means fewer service calls for stuck gear or mystery warning lights. Compare that to a typical electric retract system. When a gear motor fails, and it will, the repair invoice can easily top 4 figures. Factor in the time to chase wiring faults, replace limit switches, or rebuild hydraulic actuators, and the labor bill climbs fast. Mooney's mechanical linkage, by contrast, rarely needs more than basic inspection and lubrication. Failures are almost always due to worn bushings or misrigged cables, not hidden corrosion or burnt-out components. Despite its simplicity, the M20C cruises at 140 knots on 180 horsepower, matching the Grumman Tiger for speed, but with the efficiency that made Mooney famous. The trade-off is that inspection takes a little more time than a fixed gear design, and you have to pay attention to rigging. But in a world where complexity usually means risk, the Johnson bar stands out as a rare case where adding a system does not add headaches. For mechanics, that is worth a spot near the top of the list. The Piper Cherokee 235 and its later cousin the Dakota do not bother pretending to be sleek or cutting edge. What they bring to the table is raw displacement, a Lycoming 0540, 6 cylinders, 235 horsepower or more, turning big props at low revolutions per minute. Mechanics call this the muscle car of the sky, and not just for the sound. The philosophy is simple. A big engine running at half throttle lives longer than a small engine wrung out for every last horse. Run an 0540 at 60 to 65% power, and it just loafs along, making full time between overhauls and often more. Compare that to a turbocharged 4-cylinder that spends its life near the red line, and you start to see why shops report fewer top-end surprises in the big bore Pipers. Cylinder work is where the numbers get real. Ask a shop for a quote, and you will hear that 0540s, when run gently, can go the full 2,000 hours or more before needing cylinders pulled. Turbocharged engines, especially in high-performance singles, often see top-end work at half that interval. The difference shows up on invoices, fewer labor hours, fewer parts, and less downtime over the long haul. Mechanics appreciate the standardization too. The 0540 is everywhere, from Cherokees to Aztecs to even some twins. That means parts are on the shelf and prices are kept honest by competition. It is not all upside. The Cherokee 235 drinks more fuel than its smaller siblings, and it is heavier on the nose. But for owners who want a plane that shrugs off hard use, hauls a real load, and does not punish them with surprise bills, the muscle car approach pays off. It lands at number 6 because while durability is nearly unmatched, the fuel burn and empty weight keep it from the very top. Still, when you are staring at the shop quote for cylinder work, and it is half what a turbo owner just paid, it is hard not to smile. Beechcraft's Bonanza, especially the early straight 35, stands apart for reasons that do not show up in a spec sheet. Walk inside the tail cone or open a wing inspection panel and the difference is obvious. Every surface is coated in a thick greenish zinc chromate primer. This is not just paint, it is a chemical shield against corrosion, applied to nearly every interior cavity during factory assembly. Mechanics who have spent years patching up old metal singles know what that means. Where other airframes hide patches of white fuzz or pitting beneath decades of moisture, the Bonanza's structure often comes out clean, even after half a century. The cost of that attention to detail shows up on the invoice, but it pays off over time. Corrosion repairs on a typical unprimed Cessna or Piper can run into the thousands, with hours of labor, sheet metal fabrication, and repainting. In contrast, Bonanza owners routinely see annual inspection bills without the dreaded corrosion line item. When repairs are needed, access panels and removable skins make the job more straightforward than on many newer tightly integrated designs. Beech did not cut corners on materials either. The alloy selection and fastener quality throughout the Bonanza line contribute to its reputation for structural longevity. Mechanics who have opened up both a Bonanza and a lesser metal single will tell you the Beech is built, and it shows in the maintenance logbooks. Higher parts costs are a reality, but the savings in avoided corrosion repairs and structural surprises tilt the long-term balance. For owners who think beyond the next annual, the Bonanza's build quality is a quiet form of insurance, and that is why it earns its place in the middle of the list. The Piper Aztec sits apart from the rest of the twin-engine crowd, not for its looks or speed, but for a kind of brute reliability that mechanics quietly respect. Under the skin, the Aztec is built around a steel tube fuselage frame, a design borrowed from an era when over-engineering was not a punchline. In a world of aluminum monocoques and delicate fairings, the Aztec's skeleton shrugs off punishment that would ground lighter, more fragile twins. Shops have stories of Aztecs written off after hard landings or hangar mishaps, only to be pieced back together with new skins and sent flying again. The steel frame is not elegant, but it is forgiving, especially in the kind of rough field operations and cargo hauls that would twist a lesser airframe. Mechanics often point to the hydraulic flap and gear systems as another example of practical, agricultural-grade engineering. Where other twins rely on electric actuators or fragile linkages, the Aztec's hydraulics are simple, robust, and easy to rebuild. A typical hydraulic flap repair invoice is measured in hundreds, not thousands, and parts are rarely held up by back orders. Compare that to the proprietary electric actuators on more modern twins, where a single failed motor can ground an airplane for weeks and cost more than a set of Aztec cylinders. The Lycoming IO 540 engines are the same six-cylinder workhorses found in other Piper heavyweights, meaning parts are always available and shops know the drill by heart. Some call the Aztec ugly or thirsty, but for operators who care about uptime, it is a legend. It is not just the structure, it is the whole philosophy. Build it strong, keep it simple, and use parts you can get anywhere. That is why, when a mechanic has to choose a twin that will not let them down, the Aztec is always in the conversation. It ranks high, not because it is easy, but because it is unkillable. The Cessna 170B brings nostalgia to the ramp, but to a mechanic, it is a study in functional simplicity. The main gear is a single arc of spring steel bolted to the belly, with no hydraulics, no moving joints, and nothing to leak or fail. Instead of a nose strut packed with seals and nitrogen, the 170B rests on its tail. That design choice is not just about vintage looks, it is about cutting down on recurring maintenance headaches. Nose gear oleos on tricycle Cessnas demand regular attention. Seals wear out, fluid leaks, and a hard landing can bend the assembly or drive the invoice into four figures. A typical nose strut, rebuild on a Cessna 172 or Cessna 182, often runs $600 to $1,200 in parts and labor, not counting the downtime. By contrast, a 170B tailwheel inspection and tire change might be a $150 line item with no specialty tools or teardown required. Routine gear checks on the 170B are measured in minutes, not hours. No jacking the nose, no wrestling with compressed springs, no chasing down leaks. The spring steel legs flex and return, simple physics doing the work of a complex hydraulic system. For mechanics, that means fewer callbacks and more predictable bills. For owners, it means less time in the shop and more time flying. The trade-off is skill on the ground. Taildraggers demand a learning curve for pilots used to tricycle gear. But for those willing to master it, the payoff is a landing gear system that shrugs off abuse and rarely makes a dent in the annual. The 170B earns its spot high on the list for keeping things basic and accessible, and for being nearly bulletproof while dodging the maintenance traps built into more modern designs. Aronca's Champ is a study in pure, hands-on simplicity. Underneath the painted fabric, the fuselage is a welded steel tube skeleton, light but strong, with nothing hidden or proprietary. When a Champ gets a tear or a worn patch on its skin, the repair process is almost laughably basic. Scissors, a patch of certified fabric, a can of dope, and a few hours of patience. No rivet guns, no sheet metal brake, no specialty fasteners. A mechanic, or even an owner with the right sign-off, can finish a field patch before lunch, and the airplane is back in the air the same afternoon. Compare that to a dented aluminum wing on a typical metal single. Sheet metal repairs mean drilling out dozens of rivets, carefully forming new skins, and hours of labor. The invoice for a basic skin replacement can stretch into the thousands, and the airplane might sit in the shop for days. For a Champ, a full recover is a weekend project for a small team, and the cost is measured in fabric and glue, not machine shop hours. The engine is just as approachable. Most Champs run tiny Continental A65s or C85s, engines that have been in production since the 1940s, with parts still available from multiple suppliers. Electrics are minimal or sometimes absent entirely. Some Champs do not even have starters, just a prop to pull and a magneto to spark. The result is a knucklebuster score that barely registers. There is almost nothing to break, and when something does, it is fixed with basic tools and a little know-how. The only reason the Champ is not number one is speed, and utility is limited. But for mechanics who value total repairability and the freedom to keep flying without waiting weeks for parts, the Champ is nearly unbeatable. Van's RV series rewrites the rules. These experimental amateur-built planes put owners in charge of every bolt, upgrade, and system. For mechanics, it means freedom from certified parts monopolies and endless paperwork. Need an alternator? The Auto Parts store has it. Want glass avionics? Skip the certified Garmin panel and its $30,000 plus price tag. A full Dyne & Skyview suite with dual screens, engine monitor, ADS-B, and autopilot costs just $5,000 to $8,000 in hardware. That same setup in a certified single could double or triple in cost once labor is factored in. The savings extend beyond avionics. Owners can handle almost all maintenance themselves, and with a repairman certificate, sign off annual inspections. There is no waiting for proprietary parts or facing six-figure repair bills. Insurance companies still expect experience and careful flying. Some require transition training, and premiums may rise if a builder's reputation is questionable. Yet for a well-built RV, insurance quotes often beat those for certified singles of similar value. Here, choice is standard. Engine, prop, avionics, change them at will. No paperwork bottlenecks, no parts embargoes. The RV's Knucklebuster score leads the pack with open source parts, full access, and owner-driven costs. Across all 10 entries, one truth emerges. True aviation value hides beneath the surface. The planes mechanics choose are not about status, they are about access, simplicity, and repair freedom. In a world chasing shiny new tech, these choices prove resilience and practicality. Still win. Where others see luxury, smart owners see longevity. The smartest investment in aviation is not glamour, it is the machine you can truly keep flying. Which would you trust with your wallet?